Hence, friends, today I'm gonna talk about center of mass. Center of mass that by name suggests that m- center of any mass. Before going ahead of center of mass, let me spark a question in your mind. What is the difference between mass of a particle and weight of a particle? What is the fundamental difference? I will give you 5 seconds to think about it. Now, mass is something that is constant for a particle and weight is something that may change from one location to another. Suppose you are on the planet Earth. Here, mass of uh, an object is suppose 5 kg. Now, if you go to the star Sun, the mass will be the same, that is 5 kg. But weight is something that is defined as mass times gravity, gravitation acceleration. That is in approximately gravitation value for Earth is 10 Newton per meter square. So the weight of that 5 kg block will be 50 Newton on Earth. But the weight, the mass of star Sun is very high as compared to the Earth. So the acceleration induced to the block on star Sun when released slowly near the Sun will be far far greater than that of the Earth. So the mass will be equal to weight will be equal to mass times acceleration, that is 5 times acceleration on the Sun. You must have heard about black holes. Black holes have very high mass. I had read in class 5th that uh, one drop of water, the weight of one drop of water becomes like thousands of elephants weight, equal to thousands of weight of the elephants. So does weight also changes? In classical physics, I don't think so. I don't know about Einstein's theory or other theories, but I think mass is supposed to be constant even on the black hole. Now, here, there are two blocks, 1 and 2. Center of mass is, you can say, the center of the distribution of the mass of this block, which is supposed to be in the center. And in this block, it is in this center. If you join this axis of symmetry of this block, they will meet at the center. Yes. Now suppose this is mass m1 and this is mass m2. Center of mass is m1 and m2. So mass is m1 m2 and this is center of mass. Now this is the distance between these two. Since this block is, I am not saying the size of this block is heavier means it is heavy. It may be heavy or may not be heavy. But suppose it is heavy and it is not heavy. So mass center of mass will be close to the mass m2. If m2 is 2 times m1, then this will be like here. You can calculate it. Where will be the mass? I think I have a picture of that formula here. You read this or this both are same. The mass center of mass definition is, let me see how much time is remaining. 3 minutes. Okay. Center of mass definition is m1 times x1 plus m2 times x2 divided by m1 plus m2. That is, this is mass of one particle m1 and this is mass of second particle m2. Now m1 multiplied by, suppose this is the relative, a point of reference, a line of reference. Now this distance is x1 and this distance is x2. Now x1 and x2 are the distance from this line of these particles. Now center of mass will lie between these two particles round about here. Now m1 multiplied by x1 and m2 multiplied by x2, sum them up and divide by the total mass of these particles. M1 x1 plus m2 x2 divided by m1 plus m2. That is the formula for center of mass. 2 minutes remaining. Now suppose we have a very different looking bodies, not very symmetrical, rectangle, square, triangle, but very different. How will we calculate the center of mass of this particle? This is x-axis, this is y-axis, and this is z-axis. So, suppose there are so many particles. If you break those particles into smaller masses and calculate the distance, calculate the coordinates of those particles and their masses. You divide these particles in different masses and calculate their coordinates. After that, you will apply this formula separately. That is m1 multiplied by a first particle's x coordinate plus m2 multiplied by second particle's x coordinate and so on, and divide by total mass. And for that you will repeat that operation for y and also for z. Then you will get the coordinates of the center of mass of this body. Like this, you can see in picture like this. So many things are here to cover.